This video is going to cover the topic of proportional graphs and equations. Be sure the date and topic are at the top of your page. The essential question for this video is how do we write equations from proportional graphs? And we'll start with a couple of reminders about proportional relationships. The first reminder is that in proportional relationships, the data points have the same ratio, the same unit rate. In addition, when we're looking at a graph, if something has a proportional relationship and we see it on a graph, it will include a point through the origin, through 0, 0. In addition, when we are writing equations based off proportional graphs, we need to look for the unit rate, and that is sometimes called the constant of proportionality, and that is indicated with the letter K, which is German, an abbreviation for the German word constant that starts with a K. And in the equation writing form, that K becomes our coefficient in our equation. So those are a couple reminders. Now let's take a look at a graph and see if we can see how we could find this equation and that constant K, constant of proportionality K in our graph. So this graph shows the ratio of introverts to extroverts in perhaps our class, and it's a straight line and it's going through the origin, so I know that it is proportional. The question is, how do we find the value of K, right? That's what we need, that unit rate, to figure out our equation. So let's look at a few of the points. So I marked a few of these points both on the graph and on the side here. And remember that to find our K, our value that is our constant of proportionality, we need to take our Y value and divide it by our X that finds our unit rate. And we can do that with a few of these points to test to make sure that they are all the same. So on this first one, we'd have 2 over 1. And then I went ahead and filled in the others as well. And we can see that in each case, our 2 over 1, right? In each case, our y over x is equal to 2. So that means k must be 2. Let me change our color here. So k is 2, right? That's an important piece of information. And remember that our equation is always written as y equals our unit rate times x. So in this case, it would be y equals 2x, right? That's our equation. But there's actually a second way that we can figure out what K is, what our coefficient of our equation is, and that's by looking at the graph itself and looking at the line. So remember that our coefficient is y over x, right? So we can look on our graph at y over x. Y is our vertical change. So I can see here that I'm going up 2 every time I'm going over 1. And that's the same thing here, 2 over 1, 2 over 1, and so on. If my y value is increasing by 2, every time my x value is increasing by 1, sorry, that should be a 1, then that means my constant of proportionality, my k value or my coefficient, is 2. So that's another way we could see that too. I'll show you another example. So this graph shows the cost of tomatoes by pound. So I have the number of pounds of tomatoes going along the x-axis, I should label that, and the price, of course, going up the y. And once again, I know this is proportional. It's a nice straight line, and it's going through the origin, so that part I know. The question now is if we can find our K value, our unit rate, so that we can write an equation to show this. So once again, I'm going to mark a few points on the graph. I'm going to mark one here, here, and here. And I'm going to go ahead and write those values of the coordinates on the side. And I can use this to find my k value, right? Because remember that k is what we get when we take our y and divide it by our x. So in our first one, we'd take 1.5 and divide it by 1. Then we do 3 divided by 2. And we do 4.5 divided by 3. And in each of these instances, you should notice that we're getting the same thing, right? So that means this is nice and proportional. Our unit rate stays the same, and our K value here is 1.5, right? And of course, remember that we write our equation as y equals kx, but in this case, K is 1.5, so our equation is y equals 1.5 times x. So whatever the number of pounds of tomato is, we just multiply it by $1.50, and that will tell us how much we're paying for all of it. But once again, I want to show you that you can actually see this visually in the graph. And I just want to point out that I'm going to kind of keep track of how much my values are increasing as I go up by 1 on the x value. So I know that I'm trying to get to that black dot, so I'm going to have to go up all the way up here before I go over 1, and I'm going to do the same thing on each of these. And I can use that to help me figure out what my K value is, right? This is me going up 1.5 for every 1 that I go over. Up 1.5 for every 1 that I go over. So that means my K value needs to be going up 1.5 on Y and over 1 on every X. So there it is again. 1.5 is my unit rate, and it is my coefficient of my equation. I'll leave you here with one for you to do on your own, and it is a graph depicting the connection between soccer players and baseball players. And looking at it, it is clearly proportional. The question you have to find is what the K value is, and then go ahead and write the equation that would match this. And you can use the graph, and let me just mark here that this is 1, 3, and 5, since I left those off on here. And you can mark some points on the graph if that would help. You can look at the different coordinates, however you're going to find it for yourself, but go ahead and find the coefficient by looking for that ratio of y to x, and then fill in your equation. And remember that the essential question for this video was how we could write equations from proportional graphs. So make sure you have your notes, write down any questions you might have, and have that question answered before you get to class.